Okay, this is the start of chapter 10. This is 10.1 polynomials. You were given a handout for this, so you probably want to have that out. It's going to save you a lot of writing because there's a lot of definitions in this section. Alright, so the first definition that we're going to touch on today is the word monomial. Monomial is an expression that consists of a number, a variable, and a product of numbers and variables. So when you hear the definition, you might be wondering exactly what that means. Let's look at some examples here, because I think it's a little bit more clear when you actually see what we're talking about. Okay, a monomial, okay, is an example here. It would be x. Okay, it's a single variable. It's by itself. There's only one of them, and that's why it's a monomial. Okay, and then you have 4x. Now this is where you have a product of a number and a variable. Your number is 4, the variable is x. When there's no sign in the middle, you know that means to multiply. So the product of 4x, okay, is written here, and that's considered a monomial. Another monomial could be a number just like -3. Okay, -3 would be considered a monomial. And another example is x over 7. Okay, it's a fraction, okay, but it is a monomial. Okay, and here's another example of a monomial. It's the square root of 3 times x times y squared. Okay, so once again, that's the product of some numbers and variables. All right, so let's go over some of the things that a monomial cannot be. Okay, so monomials, they cannot be the square root of a variable. Okay, so look for example, you have the square root of x. Okay, this is not a monomial. Okay, you cannot have a variable inside of a radical. Okay, or the square root of y. Okay, these do not work. This is not classified as a monomial. Monomials also cannot have variables in the denominator. So if you're given a fraction like this, 1 over y, you can't call that a monomial. Okay, you cannot have a variable in the denominator. Okay, here's another example, 16 over x. Okay, none of those work. They're not classified as monomials. Okay, so you need to remember that. Now let's take a look at this. The word polynomial, poly means many. Okay, polynomial is one or more monomials being added or subtracted. Okay, and that's the key word in there, is added or subtracted. So let's just look at some examples here. I have 3x. Okay, this is a monomial. It's a term plus 5. All right, so I have two monomials that are being added together here. So this would be considered a polynomial. Okay, later on we might give something like this a more specific name, but we haven't got there yet. So right now we're just saying this is a polynomial. Okay, it's a monomial, or it's actually two monomials added together. Okay, here's another monomial, 2x minus 3y plus 7. Okay, you got three terms here. Okay, three monomials, and they're being added or subtracted together. Okay, keep in mind that each monomial, okay, in a polynomial is called a term. Okay, so you have three terms here. All right, here's another polynomial for you. You have y squared minus x. Okay, so all examples of polynomials, poly meaning many. Okay, and there's a little poly for you in the corner. All right, definitions. Continuing on, we have like terms. Okay, you might have heard this before. Like terms are two monomials that differ only by their coefficients. Okay, remember, coefficient is the number in front of the variable. Okay, that number can be different, but the variable, okay, and the exponent have to be the same in order for them to be like terms. And that's what the rest of the definition says here. It says they must have the same variable and the same exponent. Okay, so here's some examples of like terms. Okay, you could have 6x squared and 3x squared. All right, they have the same variable of x and they have the same exponent of 2. Okay, the 6 and the 3 are different, but that's the coefficient. Okay, that's the number in front of the variable. So that's all right, that can be different, but the variable and the exponent have to be the same. Okay, here's another example. You have y and you have 3y. Okay, both have the same variable, both have y's, and then the exponent, it's not written there, but it's assumed to be 1 for both of them, so technically they do have the same exponent. Okay, so those are like terms. Okay, so just think about it, like if they're like terms, okay, they have to be identical, as in variable and exponent. Okay, coefficients can be different. Okay, and there you go, you got some twins in the corner for you, Mary Kate and Ashley. All right, binomial. Okay, binomial is a polynomial with two different or unlike terms. This is where we're going to start to classify polynomials with different terms. Okay, and the term right now is binomial. Okay, so think about what that prefix by means. We're going to get to that in a second. Okay, here's some examples. 5x plus 2y. You've got two monomials. They're being added together. Okay, and since there's two of them, okay, this is considered a binomial. Here we go again. We got 7y minus 7z. Okay, different terms. They're not the same. They're not like. Okay, and there's two of them, which makes it a binomial. Okay, there's another one, x squared plus y squared. Okay, different variables. Okay, so they're different. They're unlike. They're not like. All right, and then over here it says the prefix bi means two. Okay, so like the word bicycle. Okay, you have two wheels. In a binomial, you have two terms. All right, so next definition is trinomial. Okay, it's a polynomial with three different or unlike terms. Okay, so that word tri, or that prefix tri, means something. I'm sure you probably know. Okay, here's an example of a trinomial. There's three different terms here. Okay, since there's three of them and they're being added together, okay, this is considered a trinomial. Okay, yes, it's a polynomial. Okay, but it's considered and classified as a trinomial. All right, then you have three separate terms here. None of them are like. Okay, they're all different. And since there's three of them, you would say this is a trinomial. So that prefix means three. Okay, and here you have a tripod. Okay, it's got three legs, and that's why they use that word tri. All right, let's go ahead and state whether each is a polynomial. Okay, and if it is a polynomial, then you need to identify it. Is it a monomial? Is it a binomial? Is it a trinomial? So take a look at this one. You have 3x plus y squared plus 7z. Okay, yeah, this is a polynomial. Okay, and it's actually a trinomial. There's three separate terms here. Okay, and none of them are like, so it's a trinomial. Oh, went a little too fast there, gave you the answer. All right, so the next one is 6m minus x over y. Okay, it looks like it could be a polynomial, maybe it's a binomial. Okay, but there's a little problem here. Hopefully you can identify it. The y is in the denominator. Okay, we said before that you cannot have this happen. This cannot be classified as a polynomial because there's a variable in the denominator. Okay, the next one, you got 5x minus 3x plus 2. Okay, well, there's three terms here. Okay, but if you have like terms, remember, you need to combine them, okay, before you can classify the polynomial. All right, so you might look at this right away and think it's a trinomial, but 5x minus 3x, that's going to give you 2x, and then this plus 2 drops down. So yes, it is a polynomial, but it's a binomial. Okay, there's two terms after you simplify or combine like terms. Okay, the next one is x over 1 plus y to the fourth. Okay, is it a polynomial? Well, I don't know. There's an x in the numerator. I don't remember if that's a rule or not. But yeah, it actually is. It is a binomial. So it's a polynomial, but it's a binomial. Okay, if you were to divide this, x divided by 1, that would just give you back x. And then x plus y to the fourth. Okay, two terms left over there. How about this one? You got the square root of x minus the square root of y. Okay, no. Okay, once again, we said that rule, you cannot have a variable in the radical, okay, or in the square root. And then the last one, yes, it's a polynomial. It's a monomial. It's one term, a and b and c raised to the second power. Okay, remember, these are products, okay, of variables here, so it's considered a monomial. All right. Now we're going to evaluate. So we have this expression here. Okay, let me turn on the inner right pad real quick. We have this expression here. Okay, it is a binomial. You got two terms here, but we're going to evaluate. So I'm going to take this -2 and I'm going to plug it in for a. Okay, and then I'm going to follow suit with all the c's and the d's over here, seeing what they equal. Okay, keep in mind that when you switch out the a, or actually any letter in this case, you want to put parentheses around it. Notice how I'm doing that now with the -2. So it's -2 squared. And then it's 2 times, well, the c value is now going to become -1. Ooh. And then the d value is going to become +1. Follow the order of operations here, so you've got to do the exponents first. -2 squared is going to give you +4. Okay, and then just drop everything else down here. All right, hopefully you can read my handwriting on this. I'm doing the best I can here. And then you got to multiply first before you can subtract. So we got 2 times -1 times 1. This is going to give me back -2. Okay, then I'm going to put this minus sign in here. I'm going to drop this 4 down, and I'm going to add. And then I got 4 plus 2, and that gives me 6. Okay, so this is how you evaluate. All right, so really all you're doing is just plugging your numbers in, okay, and you want to see what they give you as a final result. All right, so let's do that again. We're going to have 3. This a now becomes a -2, okay, and it's raised to the 3rd power. All right, and then it's plus, and then b is 3. Okay, you want to wrap that in parentheses, and it's 3 squared. Okay, do your exponents first here. So you've got -2 cubed. Okay, this is going to give you back -8. Okay, you're going to put this back in parentheses here because remember, you're multiplying. Okay, and then you've got 3 to the 2nd power. This is going to give you 9. Be careful you don't put 6. Remember, it's 3 times 3, not 3 times 2. Okay, all right, and then you got 3 times -8. Okay, so that's -24. Okay, and then you've got -24 plus 9. All right, and this is going to give you back -15. Okay, and that's your final answer right there. All right, so that's how you evaluate with that. All right, now let me get out of this inner right pad so that we can go on to the next slide. Okay. All right, so the next slide's telling you to evaluate again. Okay, let me pull back up that inner right pad here. Okay, so just keep in mind, now you have that sheet in front of you, so while I'm pulling this up, you can go ahead and you can evaluate that expression here. All right, so here it is again. Okay, we're going to evaluate, and now there's a lot of numbers here to plug in, so I want you to take your time with this. Whoops, I'm sorry. Okay, so I want you to take your time with this. All right, so we've got 4, okay, times, now this becomes -2, so you're going to switch that a out, make it -2. Okay, the b becomes 3, and the c becomes -1. All right, then we're going to subtract 2, okay, and the a is -2 squared. Hopefully your handwriting looks better than mine. And the b is going to be changed out with the 3. All right, and then we're subtracting, we're doing the 6, and then the a once again becomes -2, and d, okay, d is going to be cubed. All right, so work that magic, okay? Think about what you're going to get here, okay? Go ahead and plug these into the calculator if you'd like, okay? You can do that if you wanted to, but keep in mind, if you're doing this without a calculator, you want to take the time to show the steps here. All right, so you're going to do the exponents first. All right, so you've got -2 squared, that's going to give you 4. Okay, keep in mind that you're multiplying these numbers here, that's why they're wrapped in parentheses. All right, and then you have 1 cubed. Well, that's kind of easy, huh? All right, 1 cubed is going to give you back a +1. Okay, and then here, there's no exponents here, but I'm just going to go ahead and multiply this. I've got 4 times -2. That's going to give me -8. -8 times 3 is going to give me -24. And then I'm going to times that by 1. That's going to give me back +24. Okay, I'm going to multiply here. So I've got 2 times 4, which is 8. And then that's times 3. So that's going to give me 24. All right, let me drop this down here. Okay, I got 24 minus 24, and then I have 6 times -2. That's going to give me -12 times 1, which gives me -12. Okay, you got a double negative here, so you want to switch that to a positive. Okay, so you got 24 minus 24. Well, that's 0. Okay, so that's going to cancel out. So the only thing left over is your 12. All right. And I believe that that sums it up